Okay, welcome everyone to this new series on what is machine learning in mathematics. So what is machine learning doing in mathematics or something along those lines. My very personal, very biased account. Oh god, very biased. So I have this idea in mind for a long time, and I'm probably not the only one, that definitely a mathematician should work on replacing themselves. So right now, I'm still paid for doing research, and that's wrong. That's just wrong. A machine should do my work, right? There should be something like automated conjecturing, automated theorem proving, formal proof verification, and all of this fun stuff. Mathematicians should definitely push that further. I say that again. Mathematicians should work on replacing themselves. And that I'm still paid for doing my research is like really bad. You don't want to pay me, yeah? You don't want to pay me, nobody should pay me. Very good. So that now that it is settled, kind of the idea is, as I said, we want to replace ourselves, but somehow automated conjecturing and automated proving theorems is kind of very stuck at the moment, as far as I can tell. What is a little bit, well, quite popular, or kind of definitely growing, not quite popular, we'll come back to that, but definitely growing, is this idea of using techniques from machine learning in mathematics. And I don't mean using ChatGPT to write your slides for you. I did that. Essentially, the whole slides here are written by ChatGPT. Thank you so much for your feedback. But I really mean more like doing kind of real research, discovering new things using the approach of machine learning. And hopefully in this video series, I give you some examples of actually how that works, and also give you some indications what the limitations of this process actually are at the moment. And I think this is developing very fast, so I should say that I'm making this video series in 2025. So if you're watching that 150 years later, well, first of all, you've done something wrong, because there will be much better material 150 years later. And second, it probably has changed anyway. And I will be dead. That's definitely good for everyone. But anyway, so like right now in 2025, what is machine learning doing in mathematics? It's kind of the idea, what I have in mind here. And I feel like it's kind of a modern thing to try to think about. So in my own research, I'm struggling a lot to get from the classical type of mathematics to like a more computer-based mathematics. And I hopefully give you some indications, at least today, why I think this is the case. Well, obviously it's the case because I'm not good enough to do it, but there might be some other reasons. Yeah, some reasons I have no influence at all. But kind of what is that whole idea? So machine learning for me will always be ML, kind of very standard abbreviation. And actually I'm like super imprecise. So there's a difference between artificial intelligence, machine learning, data science, and deep learning, and for me they're all the same. Yeah. So whatever fits into my bubble, my umbrella, under my umbrella of machine learning, I will put under that umbrella. I'm very I have indiscriminate love for everyone and everything in machine learning, let's say. But really the idea of machine learning is like this very different from classical usage of computers in mathematics, or in everything essentially. Classical usage of computers is more like you give it instructions and it runs it just calculates or whatever. So machine learning is kind of a very different approach. In machine learning, you give it not really instructions. You just give it data and it does everything itself, right? It's kind of the idea of it has some form of intelligence, whatever that means, and it discovers patterns without explicit instructions. So that's kind of very important. Discovers patterns without explicit instructions. Right? Very different from just standard programming computer. And this is like, the question is then, how could we use this idea in mathematics, in the sciences? How is it used in general? And yeah, so the starting point of all of this is that this is a remarkably successful story in the sciences. So in some sense, I don't have a really good picture of all of the sciences, and probably nobody has. But in some sense, in a lot of fields, this is like very applicable and very trendy and very booming. So one of the big examples that people had was what is called AlphaFold by Google DeepMind. And it's essentially an AI model predicting protein folding. Well, I'm not a biologist, so I'm not going to tell you what protein folding is, but essentially it's this idea that larger molecules, like a protein is a very large one. Well, it's still very tiny, but it's very large for a molecule or for kind of compound. They not just get their chemical or biological behavior from, well, what kind of molecules they're made of, or what the compound is, but also how they sit in space. And this kind of applies to larger things, right? So, well, whatever. Hydrogen is hydrogen because it's hydrogen. That was the tautology. But as soon as you have more molecules in a bigger compound, it doesn't matter so much anymore what they are really made of, but very different things will come into play and it arrange itself into space due to bonding or whatever. And they will form knots or other geometric objects. It's kind of very important to detect or predict what is actually going on. And one of the big problems in biology is like proteins get a lot of their behavior just from how they sit in space, essentially. So detecting kind of protein folding or predicting protein folding is like a really important task and has many applications in very strange things like cancer. Well, cancer is not really strange. Cancer predictions and so on and so on. Right? Drug discoveries and all of that. So it's a really large thing. And AlphaFold was one of the first really successful AI models that just predicted this folding. It really a big breakthrough. So it's just one example then that you can list. You could have ChatGPT generate a list for you. Why don't we actually do that? So let's see what our friend ChatGPT has to say. So let's say I'm using just the open version of ChatGPT that you can just run yourself. So can you list examples of successful, by the way, you don't really need to type here, so grammar is like very old-fashioned at this point, so don't worry that all my grammar here is my misspellings, and don't worry about it. So can you list examples of successful applications of machine learning in the sciences? Bash. Let's see what it does. Blah 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 blah. So let's hope you just don't disappoint me because I'm doing this live. Oh, AlphaFold is just the first one. So AI in drug, astronomy, blah, climate, blah blah blah. It will go on for a while. So it's really impressive. Well, you can do that yourself. So it's really impressive what AI can do for you in the sciences. So for me as a mathematician, I'm a self-proclaimed mathematician. Maybe on paper I'm actually even a mathematician. I can't tell anymore. Doesn't really matter. Let's just pretend my preferred job affiliation is mathematician. So for me the question comes up, what about mathematics? So if it's so successful in biology, what if I've seen astrophysics and genome detection or whatever? So what about mathematics? So somehow several people I've talked to and several things I've read kind of consider mathematics like the main test for really AI, because essentially you can think of mathematics as the art of reasoning. So here's a lie. A lot of people think mathematics is about calculating. That's not true. Here's another lie. A lot of people think that mathematics is about proving theorems. Complete bullshit. Mathematics is really the art of asking questions, the art of asking conjectures, the art of approaching problems, the art of reasoning, if you want. And really simulating reasoning is one of the open main problems in machine learning. So we really don't understand how that works. And I must admit, I didn't like the word simulating here, but I was running out of a better word, because if you could really do it, it will be reasoning, right? Just because it's running on a machine doesn't really say it's not reasoning. But anyway, I was running out of good words, so I just went with simulating here. And yeah, that doesn't seem to fit together very nicely, actually. And indeed, most machine learning models do something like that. It's actually a really good picture. So how many large metal cylinders are there in the image? Well, then you just go through it. We know what large is. We were feed on data what large means. We know how to detect metal. We were feed on data what metal is. We know what a cylinder is. We were feed on data what a cylinder is. We paste everything together and there we go. So it's really good in kind of repeating things in a much faster and much better way. Which is, the brain can do that as well. So it's a really good task, and probably this will already outperform several animals and several humans as well. As I said, these slides were written mostly with ChatGPT, so it completely outperformed me. So several things it can do very well. But when it comes to new ideas, this is a little bit of a tricky thing. So you can try that yourself. So if you, and we actually did that at one point. So if you have an exam in linear algebra is something very classical where you find like 1 million of resources on the web, and you run it, the performance of students against the performance of ChatGPT, I'm pretty sure ChatGPT will do better than students. If you run it on something where there's less knowledge, ChatGPT will get worse and worse and worse, and sometimes make up something. And one of the main issues, at least I have, maybe someone has a similar feeling with ChatGPT, is that it always kind of, it doesn't tell you should be careful. It just tells you this is true. Like, anyway. So it gets worse and worse and worse the less data it has learned on. So it's kind of really good in repeating things. It's not so great in making up or kind of discovering new things. And when it then comes to really research mathematics, where there is no literature on it, you need to do it yourself, we actually really don't know how to do it. So that's a really big problem. So that's why people think kind of doing real research with machine learning in mathematics is like the test for how good machine learning actually is. So mathematics, the art of reasoning. Again, say it again. Mathematics is not about proving theorems. Just to be clear here. So that's kind of where this kind of whole story here, why I'm going to do this video series, started. Somehow mathematics is the litmus test, if you want, for AI. And there are some very impressive examples, actually, what it can do for you. So AlphaTensor is one, which I'm going to do carefully. It's essentially, so if you know what a neural network is, it's not one of the standard neural networks, it's a certain specialized neural network. And it's kind of built to analyze algorithms and improve upon them. And it was used to improve speed up certain matrix multiplication algorithms. To be completely fair here, it didn't discover kind of the fastest possible matrix multiplication algorithms. It did what neural networks can do very well at this point, like improving on things that are already known. I'll say that again. Really new discoveries, it's a bit tricky, we don't really know how to do that, but improving on things that are already known, kind of making them better, perfect. It's really good at that, and this is a good example. So speed up matrix multiplication, which is kind of fun, because one of the main problems why machine learning is how you could improve machine learning is that you have a lot of matrix multiplications. So actually speeding up matrix multiplication is kind of feeding your own system. It's a little bit of a fun thing. But anyway, kind of point of this lecture series is that I will zoom into those kind of examples. And we'll see what works and what doesn't. And if you really analyze, and I hope I will do this in kind of a bird's eye point of view, how the field is actually evolving, then there are certain things that work very well, and then just people jump like everywhere, right? If you have a hammer, you're looking for nails. People just jump on it and apply the same idea in different settings. But really new ideas, they're really rare. That's how it always works, right? People just, whatever works, people will copy it and hopefully improve upon it. That's the whole idea of Wikipedia, I guess. So it's not bad. But really new ideas are kind of a little bit lacking, in particular in machine learning in mathematics. And maybe I should have said that way earlier. So if you made it to this point and you still believe I'm going to explain the mathematics of machine learning, I'm not. I'm going to explain how machine learning can be used in mathematics. So it's kind of the other way around. Anyway, so there's also Thanks for making it this far, by the way. So there's also kind of the other question, which I'm hopefully going to address. So what it can't do for you. And again, this is probably a 2025 thing. So if you watch this video in 150 years, as I said, you shouldn't. There will be better resources. But the whole point is this can change like very, very fast, actually. And I will, let's be realistic, I will not be very, very kind with certain things. But maybe I should, because in the end, I'm a big fan of this idea. I'm a really big fan. It's still good to point out, of course, the flaws. But just this comparison that works very well for me, that the human brain is in development for whatever, 1 million years. I'm not a biologist, don't take the million too serious, but for a long time. And machine learning essentially came up in the 1950s, 1960s. So let's say that's 70 years. Yeah? That's pretty good, actually, what it can do. So, I'm a big fan of this idea, but I will, of course, maybe not of course, but I will still kind of sometimes bullshit on certain ideas. Hopefully you will forgive me. Yeah, so why does machine learning doesn't work? Well, we're trying to address that, but trying to be as neutral as possible. But at least this one time I will ramble. Forgive me for that. So if you just quit the video now, I will ramble. You won't miss anything. Okay, so why is machine learning not as popular in mathematics as it's supposed to be? Well, there are some limitations, as I said, but another reason, which is hitting me very hard at the moment, and several other people as well, is that mathematicians are not trained to do this. Yeah. So I'm talking with many other researchers, and it's pretty clear that literally 90% of all people, or maybe more, sign up for the idea that we should do this. We should use it more often. We should use it more for serious problems and so on and so on. But few people actually know what to do. And I partially blame that. Again, I'm rambling here, so forgive me. I'm trying to be more objective and less subjective in future videos, but at the moment I'm rambling. I kind of feel like we are not trained to do, and the problem is we've never really learned to do it. So if I remember back on my time when I was doing in university, like 10 years ago roughly, so what I learned is kind of really strange from a certain type of perspective. So I really like this illustration from Master's Bad Drawings, which I just stole. So things that I learned is some funny function is not differentiable at x equals 0. Things that I didn't learn is, for example, how computers work. And it's this funny thing. So little me, or whatever, whoever drew this, little whatever, blue person, little blue person and big red person. How do computers work? And a big red person answers, well, if by computers you mean 19th century mathematical analysis, and then tells you a very different story. And arguably this is actually not even 19th century, but maybe something like 18th century or 17th century. I actually have no idea, but it's like ancient in a certain sense. So somehow the curriculum is wrong. And one problem, and I really need to iterate that because it's hitting myself very hard, is why machine learning is not more popular in mathematics. It's not really a limitation of machine learning, but more a limitation of the mathematicians trying to do it. And this is just my personal experience. So many people, I say that again, it's kind of important, so many people I know would like to work more in machine learning, but don't know how to do it. And it's somehow blamed on, they're all very smart people. I'm not smart, but they are very smart. So it's not really to be blamed on them. There must be something somehow going wrong in the system. And I feel like in 2025, not having more computer-based ideas in the curriculum and more focusing on, let's say I probably shouldn't say old-fashioned, but some older ideas is maybe not the best thing to do. Enough rambling. Don't worry about it. If you have a different opinion, that's fine, right? Of course, we all have different opinions on this. But anyway, I really hope you will enjoy this kind of series where I go through the main applications of machine learning in mathematics at the moment, and kind of the main limitations that at least I see in my very biased perspective. Anyway, I hope you enjoyed this video, and I also hope to see you next time.